Hello everyone. I hope your math syllabus for JEE Advanced is complete by now and all of you are revising the concepts that you have learned in your class. But since you are preparing for JEE Advanced, so my suggestion would be that you should be solving maximum number of quality questions. Quality questions means not the conventional questions, rather some unconventional modern questions. As you can see, the previous last 2 to 3 years paper of the advance, you should realize that these days questions are being asked that are really different from the questions which was being asked sometimes back. And the main difference is that these days the questions which is being used, which is being asked actually in the JEE papers, are more sort of checking your common sense as well as the concepts that you have learned in your class. So let us see through this video. I am going to illustrate one question, and you have to learn how and when we have to use the concepts and when we have to use our common sense. So you can see that the first, this is the question that is still being written on your screen. The question is for the equation. You can see the equation 2 into 2 to the power x minus 1 into x square plus 2 to the power x square minus 2 into x equal to 2 to the power x plus 1 minus 2. We have to find the number of distinct real roots of this equation. Okay, for those who have not explored the mathematics in depth, for them this question may be a little bit tricky, maybe looking a little bit tricky, or maybe looking somehow more challenging. But if you rearrange the terms, I think this should be not that much difficult. Let us rearrange the terms first. So I'm writing the first term as it is, that is 2 into 2 to the power x minus 1 into x square, and taking 2 common from the second bracket. I'm getting 2 into 2 to the power x square minus 1 into x, and again taking 2 common, 2 to the power x minus 1. So I'm dividing both side by 2 and taking RHS on the LHS side, right? So I'm getting 2 to the power x minus 1 into x square minus 2 to the power x minus 1 plus 2 to the power x square minus 1 into x is equal to 0. Now we can see that I'm taking 2 to the power x minus 1, then x square minus 1 plus 2 to the power x square minus 1 multiplied by x. That should be, or 2 by x square minus 1 multiplied by x would be equal to 0. So you can see that x square minus 1 are appearing on the two places. So let us say x square minus 1 is equal to y. So I'm getting the equation 2 to the power x minus 1 multiplied by y plus 2 to the power y minus 1 multiplied by x, that is equal to 0. Now see how I have simplified from the first step up to this stage. And from looking at the two terms, you may think that you should assume one function f of t is equal to the power t minus 1. So let us draw the graph of this function. That is going to give you a very nice idea of how to approach in the next steps. As you can see, I have taken t axis and f of t axis, and I am going to draw the graph. So as t is equal to 0, at t equal to 0, f of t is also 0, so graph is passing through origin, and you can see this is t axis and this is the graph of 2 to the power t minus 1. Again, I am writing in both quadrants, right? This is origin. Okay, so from the graph, as you can see that two conclusions you can draw from the graph. The first conclusion is, as t increases from minus infinity to plus infinity along t axis, 2 to the power t minus 1 also increases along the graph, right? So two things now you can note down from here. The first is, if t is negative, as you can see, if t is negative, then 2 to the power t minus 1 is also negative, right? As you can see from the graph, if t is negative, then 2 to the power t minus 1 is lying below y-axis. Similarly, if t is positive, then 2 to the power t minus 1 is also positive, right? So since, which means that the sign of t and 2 to the power t minus 1 are same. Therefore, if I multiply both of them, it should be greater than equal to 0. Because 0 also, because at t equal to 0, 2 to the power t minus 1 is also 0. So this should be greater than equal to 0 for all t belongs to real number, right? So if I put t equal to x, it should be x into 2 to the power x minus 1 greater than equal to 0. If I put t equal to y, it should be y into 2 to the power y minus 1 greater than equal to 0, right? For all y belongs to real number. So again, these two terms have same sign, both of them are positive. So if I multiply both of them, so first x into 2 to the power x minus 1 multiplied by y into 2 to the power y minus 1, right? So this should be greater than equal to 0 because both factors are non-negative for all x y belongs to R. So if I slightly rearrange the terms and for the sake of solving our question, so let's say that y into 2 to the power x minus 1 multiplied by x into 2 to the power y minus 1. This is greater than equal to 0 for all x y belongs to real number. Which means that if you consider the first factor as y into 2 to the power x minus 1, second as x into 2 to the power y minus 1, which means that both of these factors have same sign. So which means that either both factors, both terms, you can say y into 2 to the power x minus 1 and x into 2 to the power y minus 1, both of these terms can be either non-negative, which means either both of these terms are positive or 0. Non-negative means positive or 0, or other possibility can be as you can see from here that their product is positive. So both of these terms, that is y into 2 to the power x minus 1 and x into 2 to the power y minus 1, are non-positive. Non-positive means either negative or 0. So as you can see that our equation at the final stage is sum of these two terms. So possibilities are that if the first the term y into 2 to the power x minus 1 greater than 0 and x into 2 to the power y minus 1 also greater than 0, in that case their sum, that is y into 2 to the power x minus 1 plus x into 2 to the power minus 1 y minus 1 is greater than 0, and therefore our equation, that is y into 2 to the power x minus 1 plus x into 2 to the power y minus 1 equal to 0 has no real roots since their sum is greater than 0. Okay, so now let us see the next possibility. Similarly, you can say that if these two terms, that is y into 2 to the power x minus 1 less than 0 and x into 2 to the power y minus 1 less than 0, in this case I am taking less than 0 case, again their sum is negative, that is their sum is less than 0, and now it should be clear to all of you that again our equation, okay, let me rewrite it. Okay, so uh, then their sum, that is y into 2 to the power x minus 1 plus x into 2 to the power y minus 1 is negative, and therefore our equation has again no real roots, right? Because in this case I'm taking both of them as negative, so their sum is negative, therefore there is no chance of their sum to be equal to 0, so their sum equal to 0 has no real roots. So now what possibility is left to be discussed is for the equation, that is our equation y into 2 to the power x minus 1 plus x into 2 to the power minus 1 equal to 0 to have real roots. Yes, now all of you should be very clear about it, that if this equation has real roots, then both of these terms must be equal to 0 simultaneously, right? This first term equal to 0 and second term equal to 0, which means there should be common values of x and y satisfying these two new equations, and so it can be either whenever x is equal to 0 or whenever y is equal to 0, right? So either x is equal to 0 or it should be y is equal to 0. In any one of these cases, uh, both equations are satisfied simultaneously. So therefore either x can be equal to 0 or x can be equal to plus minus 1. So finally x can be equal to, or you can say x belongs to minus 1, 0 and 1 this set. So you can see in the middle steps I have, so number of solution, okay, number of distinct roots is equal to 3. So this is the our final answer, and this is how these days questions are being asked